Today is day 376 of data science. It is also Friday, July 29th, 2022. And today I'm going to be doing this problem. It's another normal distribution problem. So basically, I'm trying to find the proportion of average city temperatures that are lower than that of Cabal's temperature, which is 15 degrees Celsius. So when I'm trying to find a proportion or the area below a certain point, I want to use my normal CDF function, which is the normal cumulative density function, which basically finds the density, right, or the density or the proportion or the area of all of the values up until a certain point. And so to get that function, I'm going to have to, from scipy.stats, import norm, because the norm function comes from scipy.stats. And then now I can do norm.cdf, right, cumulative density function. And then in Python, there's three values. There's your x, the lope, which is the mean, and then the scale, which is the standard deviation. Now, I like to define x as the value that I'm trying to find the area or the proportion below or above. So in this case, x is 15 because that is the point of interest. It is the point where I'm trying to find the proportion below of that point, right? And then they usually give you the mean, so 19.7, and then the standard deviation is 2. Now, if I run that, it should give me, right, the proportion of average city temperatures that are lower than that of Cabal's. Hopefully I'm pronouncing that right, but yeah. And they want us to round just 4 decimal places, so I'll just round and write 4, and then that should be the answer. Just go to Khan Academy and paste that in there to check if I'm right. All right, good. So that's the answer. But now I want to basically show how to do this with the TI-83 and TI-84. So first I'm going to just do kind of like a graph. So to put it in context, I have to import matplotlib.pyplot, right, when I want to graph. I want to also import numpy so I can get some x values here. So when I'm graphing, right, one would need x values and y values. So my x values are just going to be basically values that surround the mean. So I just kind of estimate. So if I know that the mean is about like 20, then maybe I want to start with, I don't know, maybe 0, and then maybe end with 40, and then have 1,000 values in between. So those are the 3 parameters in linspace. Linspace basically generates a whole bunch of an array of values. Array, think of it, okay, it's not a list, but you can think of it as a list. But don't quote me on that. It's just easier to understand if you just think of it as a list. It's a list of a bunch of numbers, starting at whatever point you define here, ends at whatever point you define here, and has whatever, like a whole bunch of values in between, which is, again, in this case, 1,000. So those are going to be my x values. And then for my y, I'm going to do norm.pdf, which is a probability density function. And probability density function, the difference between PDF and CDF is that PDF calculates the density at that exact point. So it's going to calculate the density for each of my x values, while CDF calculates the cumulative density. So it's basically all of the densities together up until that point x, right? While if I were to do, in other words, if I were to do norm.cdf for 15, then it would calculate all of the densities up until 15. But if I do norm.pdf 15, then it would just only calculate a density at 15, right? So that's basically the gist of it. And then same thing, I would just have to do lope over here and put in 19.7. And then scale, 2. And then I'll do plt.plot. This is where my graph comes in, and I'll just plot the x values. And I'll plot the y values. And what I should get is a normally distributed graph. All right, so that's pretty much that. Now, if I wanted to look nicer, I guess I could play around with these values, maybe make this 10 and maybe make this one 30. Something like that. So that looks a little bit nicer. And then I also like to add a title. So in this case, it's a normal distribution of average, is it city temperatures? Average city temperatures. Okay, and then I like to specify, it's not that I like to, I have to, like, it's required, to specify what the mu is and what the sigma is. So mu is 19.7, and the sigma symbol stats. Nope, standard deviation. Is 2. Run that, and then the title should appear there. Maybe break that up a little bit. All right. And then PLT dot, I like to give it like an X label. So I'll just call it temperature. I literally cannot spell temperature. Temperature in degrees Celsius. Are you serious right now? Where is the actual symbol? Degrees Celsius over here. And then just put that in there, and then run that, and then plt.y label would be the density or the proportion or the area. So that would be, I'll just call it density. Actually, proportion would make a little bit more sense. So I can run that, and that's it. And now I just like to copy the image and just kind of do it by hand over here in my whiteboard. All right, so I just paste it in here, kind of lock it in, and I just kind of redo the problem here. So in my case, I'm trying to find, what was our point of interest again? I think it was 15, right? So 15 is about, right? Nope. Whoa. You know what I just realized? It's not 15, it's 19.7, right? Yeah, that was, yep, okay. Oh no, the mean is 19.7. So the mean is right here, but our point of interest is 15. So we're trying to find the proportion of average city temperatures that were below this value right here. And so that is just literally going to be this area under the curve over here. And so how do we find that proportion? Well, again, in Python, we use norm CDF, but with our calculators, specifically the TI-83, let me get a nice thickness here. TI-83. So for the TI-83, you have to go into second vars 2, and that's going to get the norm. I don't know if it's, let me just do it real quick. Second vars 2. Oh yeah, it's normal CDF. Okay, normal CDF, and then it's literally just going to look like that, and you're just going to have to know what values to put in. But in this case, I have to put in my lower bound, my upper bound, my mu, which is my mean, and then my sigma. So what is lower bound? So, well, what is lower bound and upper bound? Basically, these two are kind of your interval. So, you know, in math class, when you had a graph and your teacher asked, oh, like, what's the domain of this function? And you would say, well, whatever number starts at here and whatever number it ends here. And so the domain would be -3, 3, right? So same thing. We're just telling the calculator what interval we want to calculate the area for. And so in this case, I'm ending at 15, I know that, but what about this? When am I actually starting? Well, the normal distribution goes on for infinity, and so technically, I'm actually starting at -infinity. But the problem is, in a calculator, there is no -infinity symbol, and so I have to use an arbitrary number that kind of represents that. And I learned from in school that I actually have to use, I don't have to, but a good number would be -1e99. And so in this case, lower bound would be -1e99 to represent negative infinity. My upper bound would be 15 because that's where I'm ending. And then again, the mean is 19.7, and then sigma is 2. And now when I just press enter, right, I should get my answer. Let me actually do it in my calculator. So -1e99, by the way, you just do -1 and then you do second comma. That's where the EE sign is. And then it's 15, 19.7, and then 2, click enter, and it should give you 0093, but if you round, it's 94. Yep, that's pretty much it. Let me not make the same mistake, because yesterday I got the mean wrong. Okay, 19.7 and 2. Okay, just wanted to make sure. Wait, I'm so dumb. I literally said it. I mentioned it in the title of the thing. Wow. Okay, great. All right, so that's it for TI-83. And then for the TI-84, it's the same thing. Second, vars 2. The only difference is the format. And it's kind of easier. So they just, when you press that, they give you lower, upper, mu, and sigma, which is kind of easier to understand, right? And you just plug in those values. So again, negative, what is going on with my pen? -1E99, 15, 19.7, 2, and then at the bottom there's a paste label, and when you hover over it, it turns black, and when it turns black, you just click enter, and then it should also give you 0094, right? And so that's the area over here, 0.0094. So to answer the question, right, the proportion of average city temperatures that are lower than that of Cabal's is 0.0094. Yeah, that's pretty much it. In other words, if we want to turn that into a percent, I believe it would just literally be 0.94%. Will even work, because you would do 2 decimal places. It would be literally like 0.94. That's it. And it makes sense, right? Because it's a really small area there. But yeah, that's pretty much it. With the TI-83 and TI-84. I have time, so I might as well just mention this. So in like AP Stat, right, this is not enough to answer the question. I believe, if I remember correctly, I have to draw the normal distribution and I have to label it with the mu and sigma, which I did over here in my graph. That's one. And then I also have to show my z-score. What I did right now is called calculator speak, and so it's literally just using my calculator, but I think College Board wants to know that you know how to do this using z-scores. And so in that case, I can show you, I guess. For z-scores, if I remember correctly, the formula, it's z is equal to x minus mu divided by sigma. And so, in other words, 15 minus 19.7 divided by 2. So that would end up being 15 minus 19.7 divided by 2. That would be negative 2.35. And so that's my z-score. And then once you have your z-score, you would use the standard normal distribution. And the standard normal distribution differs from the normal distribution with by its mean and sigma. So in a standard normal distribution, it has a mean of 0 and a standard deviation of 1. So it's the average is 0 and all of the values deviate by 1 point. So it's literally like that. And so now that you basically converted your x value into a z-score, you can now use that z-score and the standard normal distribution to calculate the proportion under that certain point. And so in other words, it would end up being negative 2.35, something like that. And it's literally the same thing visually, it's just that the numbers are different. So you would start right from negative infinity and end here, and the only difference is, I'll do it in a different color, for z-scores, the only difference would be this, literally, that's it. It's the same, it's basically the same thing, you know, if you start at -1 E99, you end at -2.35, and then, right, the standard normal means that it has a mean of 0 and standard deviation of 1. And then literally it's the same thing, so -E99, -2.35, 0, and then 1 for the TI-84. And yeah, that's pretty much it. So yeah, that's what I believe College Board wants. They want the normally distributed graph and then with the mean and the standard deviation, and they want to show the z-score conversion, and then they also want the answer, obviously. I'm not sure if there's something else that they need, but yeah, that's pretty much it. Yeah, and then yeah, I think that's it. Let me do it in Python just to kind of reinforce the point. So in this case, the graph of that would just look like the following. So if it would just be 0, and then this guy would be 1, and then this one would just be, let's see, it would just be 0 times, it would just be -3, 3. All right, so that's how it would look like, right? A normal distribution. Let me just change these values. So mu 0, and it's a standard normal distribution. And that would be the graph basically of this. Let me go back. So that's like this graph that I try to kind of draw here. It's basically this. All right. And again, let me just zoom in. So -2.35 would be kind of over here, right? And so the area that I'm trying to find is that area, and I'm starting at -infinity, ending at -2.35, and I'm trying to find that area right under the curve, and that should be, right, 0.0094. Should give you the same answer even if you're using z-scores. So that's one thing, and then let me actually get the answer with Python. I'm just gonna copy this and paste it in there, and then for this, it would just be -2.35, and then loc would be 0, this would be 1, and then run that, right, and it still gives me the same answer. And I just wanted to mention the reason I put like -3 and 3, again, it's just kind of estimating like where things would be using the mean. So if I know that the mean is 0, then I want it to be a little bit to the left and a little bit to the right, so like, you know, -3 and 3. But you can put whatever values. It's still going to be a normal distribution regardless of what values you put. It just might not look like 1 if you put like some drastic value. But yeah, that's pretty much it. Yeah, okay, anyway, bye.